This is final exam review for MAC 2311. The first question is find the average rate of change of the function over the given intervals. Function is 10x cubed plus 10 and interval for the part A is from 2 to 4. So to do this kind of problem you have to know what is average rate of change. Problem 1. So this is the formula you are going to use for the average rate of change of a function f of x on, let's say, from A to B. This is the formula you have to use. You have to find out f of b minus f of a over b minus a. That formula gives you average rate of change. In our problem, part A or for the part B, both the function is same. The function is 10 times x cubed plus 10, and for part A the interval is from 2 to 4. So you need to find out the value of this function at 2 and at 4. So if you just replace x equal to 4 here, that will give you some value. So that means it's a 10 times 4 cubed plus 10. F equal to 2 is 10 times 2 cubed plus 10, and if you plug this value back in this formula, the average rate of change will be the average rate of change is equal to this value, which is 10 times 4 cubed plus 10. You can do this calculation, find out the number, or you can just plug that value in the formula. That's up to you. Minus this one, 10 times 2 cubed. Because of this minus, it becomes minus here over 4 minus 2. You can calculate this number, find that number. You can calculate this number, find this number, and just plug the value back in the formula. If you do that, this 10 and this 10 will be cancel out, and then on the top you are going to get 10 times 56 over 2, which is 280. So that's the answer for the part A, 280. For part B, if you are going from -5 comma to +5, by doing the same calculation, your answer would be if you just plug the value, it will be 250. Okay, so the first one is 280, the second one is 250, by doing exactly the same thing. So I'm not going to repeat the part B. For problem 2, you need to find out the limit when x approaches to 7. The only thing you have to keep in mind when finding the limit for this kind of fraction is when x approaches to that value, what happens to the fraction? If it goes to 0, then there will be a problem. So you have to simplify the fraction first before plugging the value of x. But in this case, when x approaches to 7, this bottom part would not approach to 0, so you can just plug the value. 7 plus 7, 7 is square plus 8 times 7 plus 7. So I am able to do this because this limit is not making this fraction, this denominator part 0. So if you do this calculation on the top and on the bottom, it will give you 1 over 8. 7 plus 7 is 14, and then just add this number and simplify your answer. It will be 1 over 8. Problem 3. Which of the statements A through I about the function y equal f of x graphed here are true and which are false? So there are some statements we have given here. We need to find out which one is true and which one is false. Look at the graph here. Let's go to the first one. The statement limit of this function f of x when x approaches to 1 does not exist. That statement is, let's look at here. if you zoom in this graph, when x approaches to 1, so this is 1, so x approaches to 1, when you approach to 1 from left side, the function is going towards 2, from the right side it's going towards 2, so that means the left hand limit and the right hand limit, they are same. So that means the limit when x approaches to 1, it should be it should be 2, it's there. So this statement here we have given, that's the false statement. So if you go back here, the statement limit x approaches to 1 f of x does not exist, that's false. It's false. So we need to find out which one is so this one is false. Okay, for part B, the limit of the function when x approaches to 1 is 1, but by looking this graph you can see that when x approaches to 1 from left and right, the graph is approaching to 2, so this is also false. Okay, false. The statement when x approaches to 0 of this function does not exist. So look at here, when x approaches to 0 from the left, the graph is approaching to -3, but from right the graph is approaching to 0, so that means the left hand limit and right hand limit, they are not same. So this is true. The statement when x approaches to c for this function exists at every point c in from -2, 0, not including -2 and 0. So if you look at the graph here, -2 is here and 0 is here, not including 0 and -2. This graph, there is no jump, there is no discontinuity. You can see that the limit for any points from here to here, not including these boundary points, you can find the limit of this function. So the statement limit of the function when x approaches to any value from -2 to 0 does exist, so this is true. Okay, let's go to the next one. 0 to 2, from 0 to 2 means here, not including 0 and not including 2, the limit does exist. Even for the 1, the limit does exist. So for E, it's true. For F, the value of the function at 0 is -3. The value of the function at 0 is, it's not the value because there is an open circle, the value itself is 0. So this is false. The value of the function at 0 is 0, that is true. And the value of the function at 1 is 3. Look at here, the value of the function at 1 is 3, that is true. And then finally the value of the function at 1 is 2, that's false because we already know that the value of the function at 1 is 3. Okay, so that's question number 3. Find the limit of this function. The idea is, as we know that the graph of sine function is look like this, so keep going, it's a periodic function. So when x approaches to 0 from left or right side, the sine x, when x approaches to 0 from left or right, the sine x approaches to 0. So that means the limit of the sine x is 0. So we can apply that thing here. So that will be 6 times the limit of the first function minus the limit of the second function. We can use this because the limit of this function exists, the limit of this function exists. So but this limit is 0, so 6 times 0 minus the limit of 1 when x approaches to 0 is 1 itself, so that is -1. So the limit of this problem is -1. We have given a function, this is the piecewise function, and we have to answer some of the questions here. So the first one, find the limit of the function when x approaches to 4 from right side. and from the left side. So as you can see the graph here, when you look at the graph, when x approaches to 4, this is 4. From left side you are going to use this function, which is 8 minus x. So when x approaches to 4 from the left side, when x approaches to 4 from the left side, the function is 8 minus x. So you just have to plug x equal to 4 here, that is 8 minus 4 is 4. But when x approaches to 4 from the right side, you need to use this function, this graph. So if you try to find out the limit when x approaches to 4 from the right side, you need to use x plus 1. So to find the limit, just plug x equal to 4 here, that will be 5. So from the left side this is 4, from the right side this is 5. That means the left hand limit and right hand limit, they are not equal, so the limit at 4 does not exist. So we have that finding here. So let's try to answer this question. The limit of the function when x approaches to 4 from left side is equal to 4, and the limit of the function x approaches to 4 from the right side does not exist. So this is not true. This is also not true, because left hand limit and right hand limit, they do exist. The limit of the function when x approaches to 4 from positive side is 5, and from negative side is 4. Okay. Okay, so we can see that from the left side the limit is 4, and from the right side the limit is 5. From the right side limit is 5, from the left side the limit is 4. So let's go to the next part. Does the limit of the function f of x when x approaches to 4 exist? From this finding we can say that because the left hand limit and right hand limit, they are not equal, so it does not exist, because their limit from the left side and right side are different. So that answer is B. The limit does not exist because the left hand limit and right hand limit at 4, they are not equal. Let's go to part C. The limit of the function when x approaches to 6 from right side and from the left side. If you go to the graph here, 6 is here, and for the 6 you just have to use this y equal x plus 1, so you can see that the limit does exist. So limit of the function when x approaches to 6 from both sides, you just have to use x plus 1, so that would be 6 plus 1, that would be 7. So if you try to use this finding here, the limit, the right hand limit and left hand limit, they do exist and they are equal. So you can choose yes. So here the limit of the function from function when x approaches to 6 from right side is, what is that, 7. Sorry, 7. So that is 7. So from both sides it's 7. Okay, because from both sides you just have to use the same graph y equal x plus 1. So that means because the left hand limit and right hand limit are equal, so the limit of the function when x approaches to 6 exists. So the answer is yes, it does exist, and then answer is 7. Let's go to problem 6. For what values of a and b the following function continuous at every x? So whenever you have this kind of piecewise function, and if you want to find out the continuity, just make sure that the value of the function at the boundary points, that should be equal. So meaning the value of the function at -3, which is -6, should be equal to the value of the function when x approaches to -3 from the right side, because continuity happens if the limit exists at the boundary point. So what we can do, the value of the function at -3 is -6, should be equal to the value of the function when we use to the to the right side of -3, because the function is continuous if the limit of the function on this boundary point. You can see that the limit of the function when x approaches to -3 should be equal to the value of the function at -3. And that's not only for the -3, that should be true for the +1. The limit of the function when x approaches to +1 should be equal to the value of the function at +1. So the limit does exist if the left hand limit and right hand limit are equal. So for -3 case, you can see that the limit of the function, the left hand limit of the function, right hand limit of the function can be calculated by using this middle part. For when x approaches to 1, the left hand limit of the function can be calculated by using the middle part. So I'm going to use that thing here. So the function would be this is problem 6. So as we know from here, the limit of the function when x approaches to -3 should be the value of the function at -3. So limit of the function when x approaches to -3 should be the value of the function at -3. The limit does exist if the left hand limit and right hand limit are equal. So this should be equal to when x approaches to -3 from right side. So that should be also equal to the value of the function at -3. So finding the value of the function at -3 is easy. It's already -6. Now let's find out the limit of the function when x approaches to -3 from right side. For that we have to use this ax minus b. So the limit of the function when x approaches to -3 from positive side is a times x minus b, and the value of the function is -6. So if you try to find the limit, the right hand limit for this function, you just have to plug x equal to -3 here. That will give you -3 times a -b equal -6. There are two variables a and b we need to find, and we found the one equation. Let's say this is equation 1. We're going to use the second part here. The limit of the function when x approaches to 1 is f of 1. So let's go to the second part. The limit of the function when x approaches to 1 is the value of the function at 1. That's the definition of continuity. But this limit is also equal to the limit of the function from the left side, because the limit does exist when the left hand limit and right hand limit are equal at that point. So as you can see that we can find out the left hand limit of this function by using this middle part. So the limit when x approaches to 1 from left side can be calculated by using the same expression, and the value of the function at 1 is given, that is 4. And now to find this limit, left hand limit, we just have to put x equal to 1 here. So it will give you a minus b equal 4. So that is our second equation. Now we need to find out the value of a and b by solving equation 1 and 2. And I know you can solve this kind of equation. Just solve this. This is the system of equation, and solve for a and b. If you do that, you're going to find out the value of a. Value of a is equal to 5 over 2, and value of a is equal to -3 over 2. So a is equal to -3 over 2, and b is equal to 5 over 2. That is the value I found by solving these two equation 1 and 2. By solving this equation 1 and 2, I found a equal -3 over 2 and b equal 5 over 2. Okay, so just plug that value here. A equal -3 over 2 and b equal 5 over 2. By choosing a equal -3 over 2 and b equal 5 over 2, we can make this function continuous at every single point. And remember, whenever you try to answer this kind of question, you just focus on the boundary points like -3 and +1. Find the slope of the function's graph at the given point. Then find an equation for the tangent line. So we know the slope means the derivative. So for finding the slope of this function, we need to find out the derivative of this function at that point. The derivative of this function is 2x, and the value of that derivative at x equal 5 is 2 times 5. So the slope of this function at 5, 29 is 10. Now, to find the equation of tangent line, you have the equation of tangent line y minus y1 equal m times x minus x1. This is the equation of tangent line. This is x1 and y1 is 5 comma x1 and y1. This is 5 comma 29, and slope is already found, that is 10. So y minus 29 equal 10 x minus 5. Just do the simplification and bring this 29 to the right side. So y equal, just distribute this 10 here, so that will 10x minus 50, and then if you add this 29 both sides, that will be y equal 10x minus 21. Y equal 10x minus 21. This is the equation of tangent line at that point. So y equal 10x minus 21. Okay, so the problem 8 is exactly same as problem 7, finding the slope and then equation of tangent line. So I'm going to skip problem 8. Problem 9, this is the piecewise function. We would like to find out either that function is, determine if the following piecewise defined function is differentiable at x equal to 0 or not. So for that, a function would be differentiable at any point. A function f of x would be differentiable at any point a, and this is the definition of the differentiability, when this limit on the right side does exist. So a function f of x would be differentiable at a if this limit on the right side does exist, meaning the left hand limit and right hand limit of this expression does exist, meaning when h approaches to 0 from the right side, this limit should exist, and when h approaches to 0 from left side, this limit should exist. So this function would be differentiable at 0. So I want to replace this a by 0 if this limit 0 plus h, which is h minus f of 0 over h, if this limit does exist. And this limit does exist if you have the limit from the right side and limit from the left side, they are equal. So our goal is to find out what is the limit of this function when h approaches to 0 from the right side and when h approaches to 0 from the left side. As you can see that if x is greater than 0, this is the expression we are going to use for the function, and if x is less than 0, this is the expression we are going to use for the function. So when we try to find out these limits, we need to take care of this thing. So if you try to find out the limit when h approaches to 0 from right side, okay, from right side, you need to find out f 0 plus h minus f of 0 over h. 0 plus h from when h approaches to 0 from the right side. So for this one, you have to use the right side, means the top one, 2x minus 1. So the value of the f of h can be found using this 2x minus 1, so that would be 2h minus 1. The value of the function at 0 is already given, that is also can be calculated by using the same expression, because x equal to 0 can be found from here. So 2 times 0 minus 1, that is always negative 1 over h. So if you try to simplify this, here on the top you get 2h minus 1 plus 1 over h. This 1 and minus 1 cancel out. and you are going to get on the top there is 2h, on the bottom there is h. This h and h cancel out, so the limit is 2. Okay, so the right hand limit is 2. But when you try to find out the left hand limit, by doing the same thing, when h approaches to 0 from the left side, the value of the function, this part, comes from this one, x squared plus 4x minus 1. As you can see that this is for the left side. So this part, limit when h approaches to 0 from left side, f of h minus f of 0 over h. For finding the value of this one, f of h, we have to use the second part. So we have to replace this x by h from the second part. So that will be h squared plus 4 times h minus 1. And we already know the value of the function at 0, which is negative 1. It's always negative 1. So if we try to simplify this, it will be on the top, this is h squared plus 4h, negative 1 and positive 1, they will be cancelled out. And if you try to factor the h on the top and cancel out with the h on the bottom, finally the limit would be 4, because first part there will be still one h. So when h approaches to 0, that h will be 0, so the leftover would be 4. So as you can see that the left hand limit is 4 and the right hand limit is 2. That means this function is not differentiable at 0. So the function is not differentiable at 0, because to be differentiable, the left hand limit and right hand limit should be equal when h approaches to 0. And this is problem 10. Find the derivative of this function. You can use the quotient rule for finding the derivative of function. If you remember, if s of x is f over z, then derivative of this function is f prime times z minus f times z prime over z squared. That's the quotient rule. So by using that quotient rule, so for this problem 10, s of x is f of x over z of x, and we can see that f of x is given, that is 4x minus 5. G of x is also given, that is the square root of x plus 1. So f prime of x, meaning the derivative of the top part, is 4. G prime of x, meaning the derivative of the bottom part only, is 1 over 2 square root of x. So you have to know what how to find the derivative of the top part and bottom part separately. Now by using the quotient rule, this rule, you just plug the value of f prime, which is 4, times g of x, which is the square root of x plus 1, minus f of x, which is 4x minus 5, and g prime of x, which is 1 over 2 square root of x, divided by g square, which is the square root of x plus 1 square. Now you just have to simplify this. So there is a square root of x on the bottom part, so you can make the same denominator to simplify this further. And then after that simplification, I can just make it bigger. So because there is a 2 times square root of x on the bottom part, so I can make it 2 times square root of x on the bottom part by multiplying the top n and bottom one by 2 times the square root of x. By doing that, from the first part it will be 8 square root of x plus 1 minus 4x minus 5, and there is this 2 times the square root of x that will come down, and this one is also here on the denominator part. So if you try to simplify here, this is 8 square root of x times the square root of x is x, plus 8 times the square root of x minus 4x, and distribute this negative, that will give you positive 5. And then this expression 2 times the square root of x plus 1 squared. So finally, if you simplify the top part, Here 8x minus 4x is 4x plus 8 times the square root of x plus 5, and on the bottom part 2 times the square root of x square root of x plus 1 square. So that is your answer for the derivative. So the derivative of this function is this one, 4x plus 8 times the square root of x plus 5 over 2 times the square root of x parentheses square root of x plus 1 square. So I'm not going to copy it, just this is here. For problem 11, you just have to use the power rule for finding the derivative. For the first derivative, it is 8 times 3 times t square, so that is 24t square minus 24t to the power 7 by using the power rule. And now again the second derivative is derivative of this part, which is 2 times 24 is 48t, 24 times 7 is 168, t to the power 6. Okay, again we can repeat the same thing here. The derivative of the first part would be 3 times 8 times 3 times x squared. This 3 and the 3 on the denominator will be cancelled out, so eventually it will be 8x squared minus 5 plus 9 times e to the power x. The derivative of e to the power x is e to the power x itself. So if you continue that thing, the derivative of the first part would be 16x, the derivative of 5 is 0, and the derivative of this part would be 9 times e to the power x. Okay, so that's the second derivative. This one once again, you can change this 6 over x as x to the power negative 1, and you can find the value of the derivative. The derivative of x to the power negative 2, the derivative of this one is negative 2 times x to the power negative 3, which eventually you can write it down as a 2 to the power x negative 2 over x to the power 3. So if you use that trick here, the first derivative would be negative 10 over x cubed, positive 6 over x squared, and then second derivative would be 30 over x to the power 4, negative 12 over x cubed. Okay, so next problem, find the absolute maximum and minimum value of the function on the given interval. So if you have given a function and if the interval is closed interval, then there is always a possibility for finding the maximum and minimum value that we can find by finding the critical points, because the absolute maximum or absolute minimum value it occurs either on the boundary point or at the critical points. So you find the critical points, find the value of the function at that critical points, find the value of the function at boundary points, and compare them. The absolute maximum is the maximum among them, and absolute minimum is the minimum among them. So for finding the critical points, you find the derivative of this function. The derivative of this function is negative 2x, and critical point is where this derivative is 0 or the derivative does not exist. So this derivative is defined for all real number. So the only part where the critical point we can find is by equating this to 0 and solving for x. So that means x equal to 0 is the critical point. Now for finding the absolute maximum or minimum, we need to find out the value of the function at critical point and at the boundary points. So we need to find out the value of the function at a critical point, which is at 0. That means negative 0 is square plus 1, which is 1, and the value of the function at boundary point, which is negative 1. So if we do this calculation, that will be 0, and positive 2, that will be negative 3. So now to find out the absolute maximum or absolute minimum, you just choose the largest one from here, that would be absolute maximum. And by looking this 3 value, you can see that 1 is the largest one, so that is the absolute maximum. So 1 is absolute maximum. So this is absolute maximum, and -3 is the absolute minimum. So remember, if you have given a function, polynomial function or this kind of continuous function, we can always find out the absolute maximum or minimum if on the closed boundary, closed interval. So here you can see that the interval is closed. So that's why, so the absolute maximum value occurs at you can find that is 1 and occurs at x equal to 0. Absolute minimum value is a negative, as you can see, it's a -3, and that you can find at 2. So by using this property, now we can choose which one is the graph of the function. As we know, this is the function, this is the parabola, and we know that the absolute maximum value is at 1, which is 0, and absolute minimum value is at -3, which is 2. So let's compare this graph we have given. So we know that absolute maximum value is at 1. So look at the graph where you have the absolute maximum value at 1. Oh, absolute maximum value at 0. So this graph, this is not absolute maximum at 0. This graph, so these two graphs are gone. This is not the right one, this is not the right one, because you can see that at 0 the value is negative, at 0 the value is negative. But here these two graphs, at 0 the value is 1. That's right. So you need to figure out which one is the right one. You can choose at 2 the value should be -3. So at 2 the value should be -3. So this is the only one which has, you know, -3 at 2. If you see here, it's a -2, -3. That's not the right one, because at 2 the value should be -3. So this is the correct graph for the function we have given. Okay, so that's problem 14. For finding the critical points of this function, you can find the derivative of this function. This is problem 15, and derivative of this function is 2x minus 108, because the power is x to the power half. If you try to find out the derivative of, you know, derivative of this part, square root of x, this is x to the power half. If you try to find the derivative of x to the power half, that will be half times x to the power half minus 1, which is -half. So eventually it is 1 over 2 square root of x. So the derivative of the second part would be 108 divided by 2. So if you divide 108 by 2, that will be 54 over square root of x. So now to find the critical points, you just have to find out where this function is undefined and where this function is 0. So as you can see by looking this function, if x is 0, this function is undefined. So one of the critical points, so this is the derivative, which is 2x minus 54 over square root of x. So one of the critical point is 0. So another one is, you just find that one by equating this f prime equal to 0 and solving for x. So here you have to solve this one, 2x minus 54 over square root of x equals 0. And for this one, you can just, you know, do 2x equal 54 over square root of x, and you can simplify. I'm going to just multiply both sides by square root of x, and then divide both sides by 2. That will give me x square root of x equal, if you divide 54 by 2, that will be 27. Now to get rid of this square root, just square both sides. That will be x squared times x equal 27 square. I'm squaring both sides, that is x cubed equal 27 square. If you try to solve this one, it will give you x equal 9. So the critical points for this function would be at 0 and 9, because at 0 the derivative does not exist, and at 9 the derivative is 0. Find the absolute extreme values and where they occur. If you look at this graph, you can see that this open circle is supposed to be the absolute maximum, this open circle is supposed to be absolute minimum, but they are not included. And which one is the absolute maximum we don't know, which is just slightly less than 1. We don't know what is slightly less than 1. We don't know what is slightly greater than -1. So that means the absolute maximum or absolute minimum, they don't exist here because of this open circle. So you can say that there is no absolute maximum and there is no absolute minimum. So you need to find out the open interval where this function is increasing, where this function is decreasing. For that, you need to find out the derivative of this function. And remember, the function would be increasing if the derivative of that function, let's say here g of t, if the derivative of the function is positive, the function would be increasing on that interval. If the derivative is negative, the function would be decreasing. So just find out the derivative of this function, which is -4t plus 3. And now you need to find the critical points first by equating this derivative with 0. If you do that, t would be 3/4. So now you have to divide this real number line using these critical points. So there is only one critical point, which is 3/4. So we need to check where this function is positive and where this function is negative by dividing this real number on two different intervals, which is splitted by using these critical numbers. If you had more than one critical numbers, you would have more than two intervals, but for this problem there is just one critical number. So now we need to pick the testing point from this interval and from this interval for finding the value of the derivative of the function. So I'm going to pick testing point from these two intervals. So let me just use a red one here. So let's check the testing point. The testing point from here is, let's say, 0, because 0 is there and it's easy to check. Testing point from here is, let's say, 1. So now we need to find out the value of the derivative at 0, which is, if you just go back here and put t equal to 0, that would be +3. That means positive. The meaning is because the derivative at one of the testing point on this interval is positive, that means the derivative would be positive all the time here. So that means the function would be increasing, okay, here on this interval. If you find out the derivative at 1, it is -4 plus 3, which is -4 plus 3, which is -1. So by using this positivity and negativity of this derivative, we can say that the function is increasing on this first interval because the derivative is positive, and decreasing on the second interval. Decreasing on this interval. So let's go and check here. The function is increasing on -infinity to 3/4. Okay, -infinity to 3/4. The function is decreasing on 3/4 to +infinity. Now we know that the function is, the derivative is positive on the the derivative is positive on the left side. The function is increasing up to this point 3/4, and after that point the function is decreasing. So whenever the first derivative is positive on the left side and negative on the right side, at that point we're going to find out the local maximum value by using the first derivative test. Okay, the first derivative is positive on the left side and then negative on the right side, from that 3/4. So this is the boundary point 3/4 critical points. The first derivative is positive here and negative here. That means the graph should be look like this. Either it's up or down, it doesn't matter, but the graph should be increasing up to that point, and after that point it should be decreasing. So there is the possibility of, there is the local minimum we are going to find. So to answer the the part B, find each local maximum. So there is a local maximum we are going to find. So the function has the local maximum value and at 3/4, and value of the local maximum is, if you just find out the value of the function at 3/4, just plug t equal to 3/4 in this given function and do the calculation. That would be -23/8. So if you try to use this reference of my graph, then it should be somewhere here, downside, below the x-axis. That is -23/8. Find each local maximum if any. Select the correct choice. The function has a local maximum value at one value of t, and that is this one. For each local minimum, there is no local minimum. So there is no local minimum, because there is only one critical point, and at that critical point the value is local maximum. Okay. Find the antiderivative for each function when c equals to 0. So when you try to find out the antiderivative, just don't use plus c. That's what they mean. So if you try to use the power rule, the antiderivative of 5x to the power 4 is 5 times x to the power 5/5, which is eventually x to the power 5. By using the very similar trick, it will be x to the power 12/12. You don't have to write plus c because c is 0 given. And for this part, it is x cubed over 3 plus 4 times x squared over 2. That will be 2x squared minus 12x. The integration of quotient function, the derivative of sine is cosine, so integration of cosine is sine, so that would be 4 sine t plus some constant. To find out this sum, just plug n equal to 1, 2, 3, 4, 5, 6, 7, or just expand it. If you know this formula, sum of first k equal 1 to let's say n, sum of the square of the first n natural number. There is a formula for that, and that is n times n plus 1 times 2n plus 1 divided by 6. This is the formula you can apply to calculate this value, and this is actually sum of 1 plus sum of n square. To calculate this one, you can use this formula. Here the n is 7, so 7 times 7 plus 1 times 2 times 7 plus 1 divided by 6. For this part, you are just adding 1 7 times, so 1 plus 1 plus 1 plus 1 7 times, so that will give you 7. And this one you're going to calculate. If you use this formula, it will be 140. So 7 plus 140, that will be eventually 147. If you want to write down this expression as a sum, you can see that there is a pattern: 4 times 1, 4 times 2, 4 times 3, 4 times 4, 4 times 5. So sum should be 4 times k. So as you can see that there are 5 terms: 1, 2, 3, 4, 5. So this is the right choice. Okay, 4 times 1 is 4, 4 times 2 is 8, 4 times 3 is 12, 4 times 4 is 16, something like that. Okay. Find out the integration of theta by using the fundamental theorem. We know that integration of x is x squared over 2. In this case, it's a theta. Now we have to plug the limit of integration. So I can bring this half outside. Theta square is 6 pi square, 3 pi square. 6 pi square means 36 pi square. 3 pi square means 9 pi square. So 36 minus 9 is 27. So that would be 27 over 2 pi square. 27 over 2 pi square, and they are asking us to use exact value using pi. Find the average value of the function. You need to know the formula for average value of any function f of x on interval a to b. You can find the average value by using this formula. Average is 1 over b minus a integration of that function f of x from a to b. If you find the integration, that will help you to find the average value. So find the integration of x square minus 11 from 0 to square root of 22 and divide that by b minus a, which is square root of 22. If we try to do that here, let me add some extra page. Okay, for this one, this is problem 23. We need to find out the average value. Average value is 1 over b minus a. B is square root of 22. A is 0. Integration from 0 to square root of 22. X square minus 11 dx. That is what we need to find out for finding the average value. So the integration of this part is x cubed over 3 minus 11x. You just have to put this value. If you put x equal to 0, that will be gone, so we don't care about the 0. We just care about square root of 22. That is cube of square root of 22. That means it's a 22 times the square root of 22. That's cube of this value, so it's a 22 that is coming from square root of 22. That is the cube of square root of 22 minus 11 square root of 22. If we try to simplify this thing, as you can see, there is a 3, so I can make the 3 by multiplying the top one and bottom one by 3. So eventually it will be 22 square root of 22 minus 33 square root of 22 over 3. And if you subtract the top part, that will give you a negative 11 square root of 22 over square root of 22 times 3. This is cancelled out, so eventually that will be negative 11 over 3. So the average value of this function on this interval is negative 11 over 3. Okay, for this part we can use a very similar trick. Use the fundamental theorem. Integration of this part is 3x squared over 2 minus 4x cubed over 3, and now plot x equal to 0, minus and minus 1. That will give you 0 minus, put x equal to negative 1 here, that will be 3 over 2 minus cube of negative 1 would be minus, so minus minus plus over 3. If you just add these two numbers and there is a negative sign, if you consider that, that will be eventually that will give you negative 17 over 16. Negative 17 over 16. If you do this calculation, negative 7 over 6. Okay, so problem 25. This is the integration of trigonometric function. We know the derivative of tangent of x. Derivative of tangent of x is secant square of x. So integration of this one is tangent of x. So this is 3 times tangent of x. You just have to put 0 and pi over 4. If you put pi over 4, that will be 1. If you put 0, that will be 0, because tangent of tan function at 0 is 0. So it is 3 actually, because 3 times 1 minus 0 is 3. You can find the integration of sine 2x. This is the derivative of cosine 2x divided by 2 is sine 2x. So finding the integration means if you try to find out the derivative of cosine 2x, that will be negative sine 2x 2 times sine 2x. So if you try to find out the integration of sine 2x, you just have to, divide both sides by negative 2. So integration of sine 2x is negative half cosine 2x. Okay, so this is negative half cosine 2x. Because of this, derivative of cosine 2x is negative 2 times sine 2x. So if you want to go back and finding the integration of sine 2x, you just have to divide both sides by negative 2. That's how I get this negative half cosine of 2x. And now just put x equal to pi over 8, which is 2 times pi over 8 is pi over 4, and x equal to 0 is it's a 1. So half cosine pi over 4 is 1 over square root of 2 minus cosine 0 is 1. So this is, if you just simplify this negative part, it will be half 1 minus 1 over square root of 2. Okay, so this is your answer. If you want to simplify more, you can just take care of this square root of 2 sine, and if you do that, that's okay. Otherwise, this is also fine. So this is your answer. Now for problem 27, for finding the area of the region bounded by x-axis and this curve. First of all, you have to know how to draw the graph of this curve, and you need to see where this curve is above the x-axis or below the x-axis. Because if this curve is below the x-axis, you can find the area by finding the integration and making it positive. So problem 27. So if I try to plot the graph of this y equal negative x square minus 3x, as you can see that y equal negative x square minus 3x, I try to find out the x-intercept of this, which is y equal to 0. That gives me x equal 0 and x equal negative 3. So when I try to plot the graph of this function, I get 0 here, and this is my negative 3. So this is the graph. And we want to find out the area of the region bounded by this curve and x-axis from negative 7 to positive 2. From negative 7, so let me negative 7. So negative 7 is somewhere here, positive 2 is somewhere here. So we want to find out the area of this part, area of this part, area of this part. Let's say this is A1, let's say this is A2, and let's say this is A3. If your region is below the x-axis, if you try to find out the integration of this function from negative 7 to negative 3, that integration gives you the negative value. You just have to make that integration positive. So for finding the area only, you can find the, let's say A1 is the area. A1 is the area. This can be found by making the, positive of the integration. So I'm going to use this absolute value sign, integration from negative 7 to negative 3 of this function, which is negative x square negative 3x dx. The meaning of this absolute value sign is make it positive. For A2, you don't have to make it absolute value because it's already above the x-axis. Find the integration from negative 3 to 0 of the very same function. And then finally A3 is make that integration from 0 to positive 2, because eventually this integration will be negative. You have to make it positive, and you just have to add these three area A1, A2, A3. So I did this integration, and then by using the fundamental theorem, the way we are doing up to this point, this integration I got for the first part is this is problem 27. For the first part, from -7 to -3, I got -136/3. So you can try this one, -136/3. Because of this absolute value sign, it will be 136/3. For this one, I did this on my paper. I did it literally, but I don't want to repeat that thing because you know how to find the integration. It's not big deal for you. So that will be 9/2, and this one is that will be -26/3, and by making it positive. So these are the value of a1, a2, and a3, and for the area, this is a1 plus a2 plus a3. If you add this three number, eventually it will be 117 divided by 2. So the area of the region bounded by this curve from -7 to +2, you need to find out, you need to break your case like this. Because if you don't break your case like this, and if you try to find the integration directly from -7 to +2, one would be negative, another one would be negative, and another one is positive. They will be just cancel out. So you don't get exact area. So you have to just divide, you have to split the case into three different area. Okay, and eventually the answer is 117/2. We can use the very same idea here for finding the area. You can see that to find the area of the region bounded by two functions f of x and g of x, there is a formula. The formula is, let me give you that formula here, 28. If there are two functions f of x and g of x, so let's say this is f of x, which is greater than g of x, and this is g of x. Now we want to find out the area, bounded by these two curve from a to b. Then the formula for that one is integrate from a to b of f of x minus g of x. Remember, this f of x should be greater than g of x. So if we try to use this formula here, if we try to use this idea here, our f of x would be x equal to 2, and our g of x equal cosine x plus 1. So the integration, to find this area, you have to find out this integration from 0, from this point to this point, which is pi/2. F of x is 2 minus cosine of x, and there is a plus. Because of this minus, that becomes minus, and eventually you need to find out the integration of this part, and eventually the integration would be, because 2 minus 1 is 1, so integration of 1 is x, integration of cosine of x is sine x, and you just have to put pi/2. If you put pi/2, that will be pi/2 minus 1, and if you put 0, and both of them will be 0, so eventually the answer is pi/2 minus 1. So that's the area of this part, pi/2 minus 1. For this problem 29, as you can see that if you want to use the very same formula the way we did problem 28, it was clear that there are only two graphs from 0 to pi/2 where y equal to 2 is always greater than y equal cosine x plus 1, so we did not have any problem. But in this case, sometime y equal to x, we need to use y equal to x and then this red one, which is x²/24. Sometime we have to use y equal to 6, and that you can see by splitting this region into two parts. As you can see that this is the point where y equal to 6 starts. So I'm going to just split this into two parts by using, let's say, let me use the green one here. As you can see that at x equal to 6, this graph is now splitting into two parts. The first part is a1, the second part is a2. For the a1, y equal to x is the greater one, and then y equal to x²/24 is the smallest one, the smaller one. For the a2, y equal to 6 is greater than. So now whenever you try to find out the area, for finding the area a1, you need to calculate from 0 to 6, x equal to 0 to x equal to 6, x minus x square over 24. Okay, you need to find out this integration. um, so you need to find out this integration. For a2, you start from 6 and you go up to this point, which is 12. 6 minus x square over 24. Okay, that's how you can find the integration. Now you have to calculate this value, and now add a1 plus a2. If you add a1 plus a2 after calculating this value, eventually you are going to get 30. So the area would be 30. Okay, just use the fundamental theorem. Find the integration of x squared over 2 minus x cubed over 72, and plug 0 and 6. This is 6x minus x cubed over 72, plug 6 and 12, and use this part, find this part and this part, just add them. Eventually that will be 30. For problem 30, you can use the substitution method for finding the integration. So I'm going to use the substitution. U equal x squared plus 16, then du is equal to 2 times x of dx. So whenever we change the variable from x to u, we can also change the limit of integration by putting x equal to 0. So when x equal to 0, the u would be 16. When x equal to 2 times the square root of 5, u would be just put 2 times the square root of 5 here. So 4 times 5 is 20 plus 16 is 36. So this problem becomes now, this problem after this substitution, this problem becomes now from 16 to 36. I can replace this 2x, so there is still 3 because 6x can be written as 3 times 2x. 3 can be taken outside. 2x dx can be replaced by du over this bottom part can be replaced by square root of u. If you try to find out the integration of the square root of u, that will be u to the power square root of u on the top, and just put 16 and 36, because integration of 1 over square root of u is square root of u. The power is negative 1/2. So by using the power rule, negative 1/2 plus 1 is positive 1/2. So if you just put u equal 36, so square root of 36 minus square root of 16, which is 6 minus 4, which is 2. So eventually so 6 minus 4 is 2, so 2 times 3 is 6. So the answer for this problem is 6. Okay. Oh yeah, I forgot one thing here. So when you try to find out the integration of u to the power okay, so the integration of 1 over square root of u du is actually u square root of u over half. So this half flips, and then that will be 2 times the square root of u. So it's still, you're going to get the 2 here, so 2 times the square root of u. So you can bring that 2 outside, so that will be 2 times 3 is 6, 6 times 2 is 12. So eventually the answer would be 12. Okay. Problem 31. So once again you have to use the very same idea we use for for finding the area bounded by two curves. As you can see that you need to find out integration of from pi over 2, this is pi over 2 to 3 pi over 2 4 minus 4 times sine square of x dx. You have to find out this integration, and um, to find out the area here, there is a couple of things you have to know. What is the integration of, so let me just, to solve this problem you have to know the integration of sine square of x. And for finding the integration of sine square of x, so we're talking about how to find the integration of this is problem 31, sine square of x. You have to create the relation between this and, like for example, you know cosine of 2x is 1 minus sine square of x, and from here we can find sine square of x is 1 minus cosine of 2x. It should be 1 minus 2 times sine square of x. So sine square of x is actually 1 minus cosine 2x over 2. So finding the integration of this part is finding the integration of this part. So integration of sine square of x is integration of half, you can bring this here, 1 minus cosine of 2x dx. And if you remember already, the integration of cosine of 2x, we already found that in one of the problem before. Integration of cosine of 2x, yeah, integration of sine of 2x. We can use exactly the same idea here for finding the integration of cosine of 2x. So this is half, this is integration of 1 is x, integration of cosine of 2x, you can find out that is that is um, sine 2x, sine 2x, 2 times sine 2x. It's a 2 times sine 2x, because if you try to find out the derivative of 2 times sine 2x, it will be 2 times so the derivative of sine 2x is cosine 2x times 2, so that will be it should be half. Okay, so integration of cosine of 2x is sine 2x over 2, because the derivative of sine 2x is 2 times cosine of 2x, and that 2 and this 2 will be cancelled out. So the integration of cosine of 2x is sine 2x over 2. So this is the integration you can use for sine square of x here. So that is x minus sine 2x over 2. Okay, so when you try to find out this integration, the integration of 4 is 4, you can just factor out 4, the integration of 1 is x, and integration of sine square 2x is, you can use this part, which is half times x minus sine 2x over 2. Okay, half times, go back here, which is half x over 2 plus x over 2. So x over 2, because of this minus, you have to use sine 2x over, you have to distribute this half as well, so it would be sine 2x over 4, sine 2x over 4. And you have to use this limit of integration pi over 2 and 3 pi over 2. If you put this value pi over 2 or 3 pi over 2 here, it will be always 0, because 2 times 3 pi over 2 is 3 pi, 2 times pi over 2 is pi, so that will be gone, that will be just 0 all the time. The only thing is you have to plug here 3 pi over 2, 3 pi over 2 minus pi over 2, and again pi over 2. If you just put this limit of integration here, eventually you are going to get 2 pi as your answer. So the the area of this part is 2 pi. Okay, just plug 3 pi over 2 for the x. So x minus x over 2 is actually x half. So 3 pi over 2 minus pi over 2 times it by 8. So that will be 2 pi. Okay, just simple calculation. So you have to do x minus x half is x half. You just have to put pi over 2 and 3 pi over 2, and there is a 4 outside, so 4 is outside. So if you just bring this to outside, that would be 2, and that is 3 pi over 2 minus pi over 2, so that is 2 times this is pi. That's why the answer eventually would be 2 pi. For this one, we know the integration of 1 over x is ln absolute value of x. So this is ln absolute value of x from negative 11 to about negative 10. If you put this negative 10 here, because of this absolute value, it will be positive 10. So eventually this is ln 10 minus ln 11. So eventually you can write it down as a ln 10 over 11. Okay, ln 10 minus ln 11, by using the quotient rule of logarithmic function, you can write it down as ln 10 over 11. That's your answer. Find the derivative of this function. To solve this problem, you have to know, this is problem 33. So if you have y equal e to the power function of x, the derivative of this kind of function is the same function e to the power function of x times the derivative whatever you have on the exponent. So in this case, we have cosine square pi t minus 2. So y equal e to the power cosine square pi t minus 2. To find the derivative of this expression, we need to find the derivative of cosine square pi t minus 2. So what is the derivative of this part? Let's say this is f of t. F of t is cosine square pi t minus 2. The derivative of this function is 2 times cosine pi t minus 2 times the derivative of cosine function, which is sine pi t minus 2. But because the derivative of cosine is negative sign, so there will be negative sign, times the derivative of pi t minus 2, which is pi. So there are so many derivative units, you have to use the chain rule. So eventually the derivative of this exponent is negative 2 pi cosine and then sine. So when you try to find out the derivative of y, dy over dt, it's the same function times this value. So same function, which is cosine square pi t minus 2 times this value, which is negative, I'm going to put that negative here, 2 pi cosine pi t minus 2 times sine pi t minus 2. And if you try to find out this this one here, negative 2 pi cosine, sine, and e to the power same function, it looks right, this one, b1, b. Finally, the last problem, evaluate the integration of e to the power, integration of, so what is the integration of e to the power x? You can find the integration of e to the power x is e to the power x itself. So what is the integration of e to the power 7x? You have to think about the function whose derivative is e to the power 7x. So that would be e to the power 7x over 7 plus 5 times the derivative of e to the power negative is e to the power negative over negative 1, because the derivative of e to the power 7x over 7 is e to the power 7x. The derivative of this part is e to the power negative x. So eventually, and then there is a plus c as well. So e to the power 7x over 7 minus 5 times e to the power negative x plus c. Okay, so that's your answer. If you try to find the derivative of this thing, you are going to get this one. So that's your answer, and we're done. All the best.